And last class, I explained you what is, just a second. Yes. So I told you what is a vector, what is a vector field, what is dot product, what is cross product, what is triangle law. And I also told you about the rectangular coordinate system. So in rectangular coordinate system, I told you that if this is your x, y, z, okay. So a point P represented here represents, so what is this origin? Origin is intersection of x is equal to 0, y
Y
is
equals
equal
to
to
0.
0, and z is equal to 0 plane. Okay. And this point, I would just draw a little bit. So this point is suppose P, and then I will draw okay. So draw this. So suppose this is x, this is y, this is z. So this area is dx dz. Check this. This area is dy dz. This area is dx dy. And the small volume of this is dx dy and dz. This is for Cartesian. Okay. And suppose this is represented by a vector. Suppose that vector is r, this point, and that r vector is given by xi cap plus yj cap plus zk cap if the distances are x, y, and z. So if you want to get the unit vector in x direction, along the x direction, so unit vector along x direction is what? Is equal to del r by del x upon mod of del r by del x, which is actually I cap. Please see this. If you want a unit vector along, if you want a unit vector along x, y, and z, so it is given by del r by del x over mod of, do this, take the partial derivative, what you will get?
I cap.
Whatever you get is I cap actually. Okay.
Yes, sir. Yes, sir.
So what you get from here, you represent it as I cap. That is a unit vector. And similarly, if you want along y, then it is j cap, which comes by taking the derivative of r with respect to y, and taking its mod. Okay. And similarly, if you want k cap, it is del r by del z upon mod of del r by del. So this is how unit vector is calculated. Because that unit vector is that direction. Unit vector is that direction in which, suppose I am taking I cap. So it is that direction in which x is increasing steepest. X जिस direction में सबसे तेजी से बढ़ रहा है. So that's why the directional derivative works here. What is j cap? It is the direction in which y is increasing steepest. And what is this? This is k cap. This is the direction in which z is increasing the steepest. All right?
Yes, sir.
सबको समझ आ रहा है ना? So ये वाला एरिया अगर कभी लेना हुआ anywhere, so please see this area is dx dz, because this plane will be cutting the y-axis perpendicularly, this plane. So that's why no dy. This is cutting x-axis and this is cutting z-axis. Can you see all that? बोलो भाई.
Yes, sir.
What about others? Are you understanding?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now I will discuss the second coordinate system, and that is circular. Can I erase this all? One part is to learn the vectors, basics of the vectors, and another part is to apply. Like today, I was teaching in offline EMT class, so there some displacement current was to be calculated. So in a single question, we used Faraday's law. Then we applied Stokes' theorem of this vector calculus and Ampere's law. So all of that in one. So what I want to say is that the feeling of vector fields and vector calculus comes actually when you apply it to physics. So in that situation, you learn a lot. Okay. So about the cylindrical coordinates, so let us discuss the cylindrical coordinates. So cylindrical coordinates are, so now we will connect every coordinate to Cartesian coordinate because we have understood Cartesian coordinate and that is the basic one. So cylindrical coordinates will be represented like this. Suppose we have this XYZ coordinate and you have a cylindrical symmetry. So for the same point P, point is same. Initially we had X, Y and Z. Now that X, Y, Z coordinates will be transformed into rho, phi and z. Okay, it will be transformed into new coordinate system, that is the cylindrical coordinate system. So the same point P x comma y comma z will be written like this. Put a perpendicular here on the xy plane and connect it with the origin So the angle made with the x-axis anti-clockwise is phi, and that is called azimuthal angle. What it is called? Azimuthal angle. So I hope you can imagine that z-axis is coming out of the board, and this is the xy plane. So if you put a perpendicular on the xy plane and connect it to the origin, so that vector sweeping on the xy plane, this vector will be sweeping on the xy plane. This is the rho, and this is the phi. Can you see that? So what is the angle between rho and z?
Hello, sir. Can you repeat the question?
Puneet, somebody else will answer. Sachin, can you answer? Sachin Chaudhary.
Sir, it may be phi.
No, I am asking angle between rho and z.
Rho and Z.
Hmm.
So 90 degree.
Yes, very good. So because this is xy plane, na?
Yes, sir.
So this is perpendicular. So angle between rho and z is 90 degree. और मैंने बताया था कि जो यूनिट वेक्टर्स होते हैं, तो देख लो, रो हो गया, फाई हो गया, और ये जो हाइट है सेम z, जो पहले z था, ये हो गया तुम्हारा सिलिंड्रिकल कोऑर्डिनेट. This is known as cylindrical. So can you see the conversion between this? So initially आपके पास क्या था? You had this vector, हाँ? इसको आपने r लिखा था, और अब नए में क्या क्या आ गया? इसको आपने x, y, z में लिखा था. Now you got three vectors, rho, phi and z, and I told you that unit vector is in the increasing direction of that vector. Do you remember that?
Yes, sir.
So rho will have unit vector in the increasing direction of rho. This will be rho cap. Please see this. Phi will have a vector that will be in the increasing direction of phi. So this will be phi cap. And z will have a vector that will be increasing here. So it will be z cap. So you just transform all these vectors here, just keeping it parallel. So this is your rho cap, and perpendicular parallel to this is your phi cap, and this is your z cap, and all of the three are perpendicular. Can you see that?
Yes, sir.
So these are your new unit vectors. New unit vectors in cylindrical coordinates. So this is the cylindrical coordinate system. Okay? You can just think about this point touching a cylinder and going like this, and you can just imagine a cylinder like this, and these two are parallel, and this is the point which we have represented in terms of rho, phi and z. Now you can correlate them also. It's very easy. Like we can write the values in terms of all that. So for example, if I want to write the value of x, please see this. X is equal to rho cos phi. Can you see that? Rho cos phi. Yes. Resolution of vector.
Yes, sir.
and y is equal to rho sin phi. बताओ भाई, किसी को कोई डाउट है तो पूछते रहना, नहीं तो फिर सो अ राइट हैंडेड सिस्टम इज फॉर्म्ड. जैसे एक राइट हैंडेड सिस्टम हमने ये पहले बनाया था, देखो x y और z. This is a right handed system. Okay, you have to make the three orthogonal axes like this. Now there are three orthogonal axes, rho, phi and z. So they are like this. So it is rho like here, rho cap, and phi cap is like this, phi cap, and this is z cap, like this. Can you imagine all these three perpendicular, rho going perpendicularly inside the board? Yes.
Yes, sir.
So this is also a right-handed system, rho, phi and z. So like this was x, comma, y, comma, z. This is rho, comma, phi, comma, z. This is a system, new orthogonal system, which will cover the Euclidean space. So these are basis vectors. So basis vector means they will span over all the space. कोई भी वेक्टर आपको लिखना है, you can write it in terms of them. कोई भी ऐसा वेक्टर नहीं हो सकता यूक्लिडियन जो इन तीन वेक्टर्स के टर्म में ना लिखा जा सके. इसलिए हम कह रहे हैं कि दिस विल स्पैन ओवर होल ऑफ द स्पेस. एंड z इज इक्वल टू z. z इज इक्वल टू z. Check this. And I told you, if you remember, I told you that three planes perpendicular to each other, they made your Cartesian coordinate. You remember that? So here also, three perpendicular planes will make the cylindrical coordinate. So one plane is this, which I have made like a door. Can you see it like a door? अगर डोर क्लोज कर दूं तो फाई की वैल्यू कितनी हो जाएगी? 0. So this is like a door. Okay, so this is one plane. तीन प्लेन से मिलके बना है ये पॉइंट. Three planes. So first plane is this. What is this plane? What is the constant about this plane? What is constant for this plane? Yes.
Z.
Sorry. Z is not constant by on this plane. This, if you go take different things, you will get different value of Z. Phi is constant. So this whole door is having same phi, right? So this plane is phi is equal to constant. Is that okay? What is the second plane? Second plane is
Rho equals to constant.
Z is equal to constant. Plane slicing down it like this.
Yes, sir.
Yes? सबको नजर आ रहा है? बोलो भाई. Can you see this? If I plane is Z is equal to constant is slicing it down.
Yes, sir.
So it is like this actually. You have to make a circle which is going like this actually. Okay, like this, and this will become the center, and this is the plane that will slice down. Okay, so when you put it here, here also you have to change it little bit. It will go like this. Okay, so ये plane नजर आ रहा है, ये वाला? Sorry. So this plane is Z is equal to constant plane. So two planes are clear. Yes.
Yes. Yes, sir.
And third plane is rho is equal to constant. That is like a surface. So if you want to make a surface in which this radius is constant, so what you will do? You will make it like a cylindrical surface. Yes. So this curved surface में क्या constant है? What is constant in the curved surface? Rho. So the three planes are phi is equal to constant, z is equal to constant, and rho is equal to constant. Is that okay? These are three planes. And if you want to see it in a better way, I would just show you on the screen. Please see this. Can you see now properly the three planes cutting?
Yes, sir.
You can take the screenshots if you want. So you can see that the three planes are phi is equal to constant, rho is equal to constant, and z is equal to constant. The top one is z is equal to constant. Yes. And the unit vectors will be in the increasing direction of those vectors that is shown here. Is my cursor can be seen?
Yes, sir.
So please see here. Phi is increasing. So you draw perpendicular to the rho in the increasing direction of phi. So this vector is transformed here. मैंने parallel करके बनाया था ना, पहले यहाँ बनाया था, उसके बाद यहाँ shift किया था, right? And rho is increasing, so this will be the direction. So that vector is shifted here. See, rho. ये a rho, a phi, all these are notations for rho cap, phi cap, okay? And this az is z cap. This is another notation I will tell you. Okay? Yes or no?
Yes, sir.
Yes, sir.
And just see this. And if you want, you can make this. So this will be the small volume in the cylindrical coordinate, like I made in the Cartesian also, na? I made dx, dy, dz. Yes. So you make the same volume here and see the result. So this part can be written by, this is rho and this small angle is phi, because this whole plane is having angle phi. So this small angle is d phi. So this small distance will become rho d phi. Angle is equal to arc upon radius, right? So arc is equal to angle into radius. So radius is rho. So this curvature, can you see this? मेरा cursor देख रहे हो?
Yes, sir.
Yes, sir.
This becomes rho d phi. Copy में सब लोग बना लीजिए इसको. Make this in copy. So this distance is rho d phi. So this will become rho d phi. This height is dz, is still dz. You know the third coordinate z is same. So I know this, I know this. Now I want this, and this is simply d rho because this is parallel to this. This small is d rho because this is rho and this is d rho. Yes?
Yes, sir.
So नीचे जरा मार्क करोगे तो ज्यादा आसान रहेगा लिखना. Mark it here. mark it here. ये क्या है बताओ भाई सब लोग. What is this? Rho d5.
Rho D.
What is this?
D row.
D rho. D rho. And what is this?
DZ.
dz. बस हो गया. अब जरा सब लोग बताएंगे. धीरज भाई क्या बात है? कुछ कहना है धीरज जी? आराम से बना लो. And I will WhatsApp you also, or you can take a screenshot. Screenshot can be taken, na?
Yes, sir.
So now tell me, what is this area equal to? Where is my cursor? This area.
Rho D5
Rho
DZ.
DZ.
Mark कर लो. Mark it. Whenever this small area will be needed, n times you will need in classical mechanics, in electromagnetic theory, in statistical mechanics. This area is most. So this is what? You know this area? This area is on the curved surface area of the cylinder, right? ये तो outer area है ना? तो ये सबसे ज्यादा यूज होगा.
Yes, sir.
This is the curved surface area of the cylinder. Yes? किसी को कोई doubt?
Yes.
So if I integrate this, what I will get? 2 pi RH. वही तो होता है ना curved surface area of the cylinder. So most of the time this will be used. And what is this area?
D row DZ. D row into DZ.
Very good. D rho into dz. इसी सब में confusion होता है. Can it be seen clearly? Puneet?
Yes.
And what is the top area? तो 3 ही area है, बाकी तो सारे equal ही हैं. जितना ये है उतना ही अंदर वाला है, जितना ये है इतना ही पीछे वाला है, जितना top है उतना ही bottom है. So what is the top area?
Rho D5.
Rho d5 d rho. Rho d5 d rho. Is that okay?
Yes, sir.
Very nice. So can I stop sharing? Everybody noted it down?
Yes, sir. Done.
Yes, sir.
Very good. Yeah. So now we have got we have related it with the Cartesian, but we want unit vectors. We want unit vectors now. So your x is related to rho cos of phi. Okay? Yes?
Yes, sir.
And I want a unit vector. So we know x cap, y cap, j cap, correct? We know them. We know
Yes,
the
sir.
unit vectors x cap, y cap, j cap. So now we want to write the unit vectors. What? Rho cap, phi cap, and
J cap.
z
Z
cap.
cap.
This I want to write. So I will just make a table in which all unit vectors will be accommodated. So it is x cap, y cap, z cap, and here rho, phi, and z. So if I know the component, that means I know the relation between them. So this is cos phi, this is sin phi, this is 0, this is minus sin phi, this is cos phi, this is 0, this is 0, 0, this is 1. Okay, so these are the just dot product of vectors. So if I know the dot product, I know the relation. Dot product of the vectors. You check clearly. So अपने उस diagram में देख सकते हो, if you, what is the dot product between two unit vectors? It is just cos of the angle between them, right? By
Yes, sir.
suppose you have two vectors like this, and this is unit vector a cap, this is unit vector b cap, this is phi. So what is a cap dot b cap? It is just, अरे अपना माइक ऑफ रखो भाई, किसका है? किसका है? प्लीज ऑफ कर लो माइक. कर लिया ऑफ? Okay. So it will be magnitude of a, magnitude of b cos phi. So obviously magnitude is 1, so that will be only cos phi. Yes or no? Yes. So एक बार चेक करना जरा सबके बीच में, देखो ये समझ पा रहे हो सब लोग? अब बिकॉज x और z परपेंडिकुलर है, इसलिए इसका cos 90 0 है, इसका cos 90 0 है, इसका cos 0 1 है, राइट?
Yes, sir.
एक बार चेक करो डायग्राम में ये चीज सभी लोग. Can you check this in diagram? Like this. This was x, this was y, this was z, this was point P, and this was rho, this was rho cap, this was phi, so perpendicular to this was phi cap, and this was z cap. Z cap. And if you just take these components, please see this. This is x cap, this is rho cap. So what is intermediate angle? Cos phi. So see, cos phi. So then x cap, phi cap. So x cap is this and phi cap is this. So what is angle between x cap and phi cap? बोलो. S cap and phi cap के बीच का एंगल कितना है? Cos of, I mean सिर्फ एंगल पहले बताओ. Phi plus 90. देखो, can you see everybody? भाई x cap से phi cap के बीच का एंगल देखना है, तो इतना एंगल phi है and 90 more. Yes or no?
Yes, sir.
This angle is 90. So it is phi plus 90. So if I want to write the dot product between x cap and phi cap, it will be cos of, बोलो भाई, 90 plus phi, which is minus sine of phi. हो गया? Then y cap and phi cap. So y cap and phi cap is this is phi cap, and this is y cap. This is y cap. So what is angle between phi cap and y cap? Tell me. बोलो भाई. x cap और y, ये phi है, ये टोटल 90 है, तो 90 माइनस phi नहीं हो जाएगा?
Yes, sir.
इतना क्यों परेशान हो रहे हो? So cos of 90 minus phi, which is sin phi. So it is written here. And y cap, phi cap. Yes. So रो कैप के साथ कितना एंगल था फाई का?
90 degree.
नहीं, फाई कैप का, सॉरी रो कैप का वाई के साथ अभी किया ना.
Yes, sir. 90 minus 5.
90 माइनस फाइव, तो उसमें 90 ऐड कर दो तो सिर्फ फाई हो जाएगा. सो दैट्स व्हाई कॉस फाई. तो हो गया सारा, डन. कोई डाउट हो तो पूछ लो. Any doubt? Anybody wants to ask anything? No. हाँ,
Yes.
क्लियर है ना?
Yes, sir.
All the dot products are clear? Very good. इसको दोबारा भी देखना सब लोग अपने आप. And now you see, because dot product is known, so that means we can write any vectors in terms of any vector. Like what you want to write. Suppose you want to write x cap. Please see this. So it can be written as, bolo, rho cap cos phi plus phi cap minus sin phi plus z cap into 0. Got it?
Yes, sir.
Y cap. Because how you write vectors in terms of their resolution, na? In terms of their components. Like please understand this. When I tell you this is r and this is theta and this is x, I told you this is x, this is y. Right? So these are the vectors. So now how r vector is written? R vector is written by its, बताओ भाई, x,
Sir, xi cap plus y
x cap
Plus YG.
plus y, y cap. And what is x? It is r cos theta, x cap. What is y? It is r sin theta, y cap. So actually what we write here is, if you take dot product of this and this, you will get this. See? If you take dot product of this and this, you get this. We don't realize it because it is so simple. Are you getting it or not?
Yes, sir.
R dot x cap is x. R dot y cap is y. So it is the dot product which is written here with this. Okay?
Yes, sir.
So this is x cap. And then what is y cap? What is y cap? बताओ भाई. Rho cap
Sin
Sin-
pi plus sin pi cos
plus phi cap
cos phi.
cos phi. And what is z cap?
Z cap.
Z cap. So this is the unit vectors. है ना कितना आसान?
Yes, sir.
और अगर इसको हटा दूं, अगर suppose I want to write, now do it by yourself. Suppose I want to write rho cap, then x cap cos phi,
Sign phi.
y cap sin phi, and phi cap x cap minus sin phi plus hmm, y cap cos phi.
Yes, sir.
And z cap is z cap. See this? Got it?
Yes, sir.
Now, if I want to know, अगर आपको याद हो तो मैंने ऐसे लिखा था, देखो, r is equal to x I cap plus y x. Let me write it like this: x unit vector of x plus y unit vector of y plus z unit vector of z. ऐसे लिखा था ना?
Yes, sir.
So if I want a vector which is in the direction rho cap, huh? So what I will do? Del x by del rho. बोलो भाई.
Second, can you repeat the statement again, please?
Suppose I want the component of rho. So suppose I want the component of this, a unit vector in the x cap direction. That means in the x direction. So what you did? Del r by del x by mod of del r by del x. ये तो किया था, तो x cap
Yes,
आ
sir.
गया था.
Yes, sir.
So ऐसे ही del x by del rho करें अगर, तो कितना आ जाएगा? What we will
So
get?
cos phi.
We will get cos phi and if I go for, so this was del x by del rho, and similarly get del x by del y by del rho.
Sin phi.
What you will get?
Sin phi.
Sin phi. And del z by del rho? 0. Yes? यही तो यहाँ लिखा हुआ है. Correct?
Yes, sir.
Now write del x by, अब phi का निकालें, phi कैप का, del x by del phi कितना आएगा?
Sin phi के. Sin.
Minus
Sin phi.
rho minus sin phi.
Yes, sir.
Next, del y by del phi.
Rho cos phi.
Rho cos phi.
Rho cos phi And del z by del phi
0.
0. देखो दूसरी रो रेडी है. और थर्ड तो वैसे ही क्लियर है. तो अपने इस फॉर्मूले से भी निकल गया. ओके.
Yes, sir.
तो एकदम सेम पैटर्न पे we can do the third one, that is called spherical coordinates. Spherical coordinate system, बिल्कुल similar. So it is like this: x, y, and z. This is origin. This is that point P, which is actually x, y, z. Now this is rho, sorry, r. This is r. Don't confuse it. Sometimes in cylindrical coordinate system, this is written as r, but this r is not that r. Okay, that r is this on the xy plane. So if I make it like this, it is the same angle phi. So r phi, and this angle is theta. So this makes the spherical polar coordinate system. So this was rho there, na? In cylindrical coordinate system.
Yes, sir.
So this is r sine theta here. Can you see it by resolving it r into components? So what is z here? You can see z is r cos theta. And what is this? Rho here, rho is r sine theta. So what is x here? Now resolve it again. X is r sine theta cos phi. Can you see that? Resolution of vector कैसे play करता है? इसको इधर resolve किया, अब इसको इधर resolve कर रहा हूं to write the value of x. What is the value of y? It is r sine theta, but sine of phi, because you will resolve it towards y. And what is z? Z I already wrote. Z is r cos of theta. Now what are the unit vectors? So obviously phi cap will be this vector. In the increasing direction of phi, it will be same here. This will be r cap, and r cap is this. Theta cap is this. In the increasing direction of theta. Theta cap, देखो ये theta है, increasing direction of theta. ये r है, increasing direction of r. And this will be perpendicular to both. It is going into the board. This will be phi cap parallel to this. So this system is r, theta, and phi. This is the right hand system, r, theta, and phi. And these are the relations. Getting it?
Yes, sir.
Now again, this system is represented by the planes. So you can imagine again the same phi plane will be same. Phi is equal to constant. Bolo bhai.
Yes, sir.
And r is equal to constant. You can imagine a surface, a spherical surface, where r is equal to constant. Can you imagine that?
Yes, sir.
And theta is equal to constant will be a cone like this. Because if theta is constant, this vector can revolve like this at same theta. So that will give that. So these three things will make the three surfaces which are perpendicular. So a point in Euclidean space is always discussed in terms of three perpendicular surfaces. So in this case, it is one this plane, phi is equal to constant. Another one is uh, the theta is equal to constant, which is cone. And what is the third one?
Phi is
R
equal to
constant.
Is constant.
No, phi constant,
theta
then
constant.
R constant, R constant.
Yes, sir.
Okay, so that will be a spherical surface. So let me just show you the same thing again. Yes, you will note down it in your copy. It will be very valuable. Even sometimes ऐसा होता है कि हमें एक बार समझ आ जाता है, but हम दोबारा पढ़ते हैं, दोबारा confuse हो जाते हैं. So you should always note things properly so that you can visit it again. Sharing it. Please say this. So see the three surfaces. One is phi is equal to constant that you already know. Yes or no? Phi is equal to constant you already know.
Yes, sir.
And the cone, which is here, please see this. This is the cone. Yeah, can you see this white thing is a cone that I draw there? This, like this, it will go. It is a cone. Okay. And बड़ा bad सा cone बनाया है मैंने, but I hope you understand. It will be like this. Okay. And a spherical surface, can you see this? This is spherical surface. R is equal to constant, a sphere. So phi is equal to constant is a plane, R is equal to constant is a sphere, and theta is equal to constant is a cone. सबको समझ आ गया?
Yes, sir.
Yes, sir.
Very nice. So keep it with you and see this now. I have described you the unit vectors. Can you see the unit vectors? R के बढ़ने के direction में AR means R cap, A theta means theta cap. This is another notation of unit vectors. And A phi means phi cap. Can you see this? Unit vectors. And then please see a small volume here. So please understand, this is angle phi, this is a small angle d phi. Is my cursor seen properly? What will be this? This?
R sin theta d phi.
Phi, what is this? This is R. What is this distance? R sin theta?
Yes, sir.
Please see in your copy. This is R sin theta. So this is now a radius. So this is the arc. So arc will be equal to radius into bolo
Angle.
angle. Our angle is d phi because this angle is phi. So this small angle is what? D phi. So this will become, this small distance will become R sin theta d phi. And this will be dr because it is in the direction of R. So this one is R and this small distance is dr. Okay. So what will be this? This will be R d theta, again angle coming into picture. So ये थोड़ा समझना मुश्किल है. देखो ध्यान से, this one. So when you take this arc, in this arc the radius is R, but angle is d theta. Can you see that? Because this is angle theta. This is angle theta. So in that direction it is d theta. So that's why it will become R d theta. Now please tell me this, the curved surface, small area on the curved surface. सबसे important यही है. What it will become? Multiply these two. Length
R
into
R
breadth.
square sin theta d
R
theta d
square
phi.
sin theta d theta d phi सबसे ज्यादा यूज होगा. ओके और इस एरिया को अगर लेंथ से मल्टीप्लाई कर दें तो वी विल गेट वॉल्यूम. सो आर स्क्वायर साइन थीटा डी फाई डी आर.
Yes, sir.
सो दिस विल बी द स्मॉल वॉल्यूम ऑफ द स्फीयर. तो ये भी नोट कर लो सब लोग प्रॉपरली. नोट इट डाउन. And then I want you to again draw this table by yourself. Let me show you. Everybody will try this and make this table by yourself. Can you see it now?
Yes, sir.
The same table. जो ये ax ay az लिखा है इसको x cap y cap z cap लिख लो. Write it x cap y cap z cap और ऊपर लिख लो r cap theta cap phi cap and make this table. And you know that it is cos of angles between them, right? So ये सब निकाल के देखना. And by the same method where I took the derivative to tell you how to calculate the component, that is much easy na. Just you have to take the derivative and write the components, right? उससे भी सारा लिख के देखना. Okay? नोट कर लिया सबने? This one?
Yes, sir.
तो ये सारा आपको निकाल के देखना है डॉट प्रोडक्ट जो मैंने बताया है. ओके चलो. Can I stop here?
Yes, sir.
Okay, then let's meet tomorrow. Any doubt anybody has?
No, sir.
Okay, let's meet tomorrow. Thank you.
Thank you, sir.
Thank you.
Thank you. Good night, sir.
Thank you, sir.